What does it really mean when multiple cosmic events begin to line up around Earth at the same time? Our planet isn't suddenly special, but it may be unusually well positioned. The Sun is entering a more active phase, releasing powerful flares and streams of charged particles that sweep past Earth's magnetic shield. At the same moment, distant visitors, like comets, familiar meteor streams, and subtle lunar alignments add energy to an already dynamic system. None of this unfolds with drama, but with patterns, timing, and consequence. Tonight, we'll calmly explore how solar activity, space weather, and Earth's own responses may be connected in ways we're only beginning to understand. If thoughtful science like this resonates with you, please like and subscribe. Now, let's begin. The Sun has been feeling restless lately. Not in a dramatic or sudden way, but with the kind of slow, simmering tension that builds quietly before anyone thinks to name it. From our place near Earth, this restlessness first showed itself as a strong release of energy from the side of the Sun facing us directly, a flare, measured by instruments as a 5.0 M-class event, unfolded like a brief but powerful flash of stored tension letting go. It was followed not long after by another release, gentler but still notable, a 3.3 M-class flare, lingering just long enough to push something larger outward. When the Sun releases energy like this, it does not only send light. Light travels fast, crossing the space between the Sun and Earth in about 8 minutes, arriving quietly and all at once, along with it. Though, the Sun can also release clouds of charged particles, slower and heavier, drifting outward like expanding breath. This particular release carried the shape astronomers call a partial halo, not aimed directly at Earth, but wide enough that its outer edge may still brush past us, not a direct collision, more like the edge of a passing current, expected to arrive in roughly 3 to 4 days. If it holds together along the way, these moments did not arrive alone. They were part of a larger rhythm on the Sun's surface, shaped by dark, restless regions where magnetic fields knot and twist. Several of these sunspot groups have been active for weeks now. They first formed while facing Earth, then slowly rotated out of sight as the Sun turned, continuing their activity on the far side. Unseen, but not inactive. Now they have returned, emerging again along the eastern edge of the Sun from our perspective, beginning another long passage across the face we can observe. Their return brings familiarity and also attention, because their history tells us they are capable of releasing energy again. As light from the flares reached Earth, it met the planet not at the surface, but high above it, in a thin, sensitive layer of atmosphere known as the ionosphere. This region responds quickly to incoming energy, especially the lowest part of it, sometimes called the D region. When bursts of solar radiation arrive, this layer thickens slightly, absorbing radio waves instead of letting them pass. For a short while, radio signals fade, not because anything is broken, but because the air itself has changed character. On the daylight side of Earth, where the Sun's light was falling at that moment, this effect was strongest. Large parts of Africa and surrounding regions experienced this quiet interruption, while much of the Western Hemisphere slept. unaware. The instruments that watch the sun notice the change clearly. Satellites positioned far from Earth trace the flow of X-ray energy continuously, drawing smooth lines that rise and fall with solar activity. For some time, the line hovered low, in what scientists describe as B-class levels, then gently climbed into class territory. As the returning sunspots rotated into view, a modest flare appeared there, almost tentative. Then, suddenly, the line rose sharply with the 5.0 and 3.3 M-class events, holding higher for longer than usual. The shape of that rise matters. Long-duration flares are the ones most likely to push matter outward, and this one did. While this unfolded, Earth continued its own quiet routines. Many people slept deeply. Others found themselves waking briefly, then drifting back into rest. There is no single explanation for such nights. Only the reminder that our planet exists within a web of energy that changes subtly, even when we do not consciously notice. Above the atmosphere, the magnetic field adjusted, absorbing and redirecting charged particles as it has done for billions of years. Beyond the Sun and Earth, the wider solar system was also in motion. A comet, known to astronomers as A6 Lemon, approached its closest point to the Sun. Its perihelion, passing above the flat plane where most planets orbit. As it drew nearer, sunlight pulled a long, luminous tail from its surface, stretching dust and gas behind it. From our vantage point, its path aligned roughly with the same region of the Sun now occupied by the active sunspot groups. The alignment itself carried no force, only geometry, but it offered a striking reminder of how many paths can cross the same space at once. The Moon, too, was approaching a moment of closeness. A full supermoon was building toward its brightest night, when it would sit at one of its nearest distances from Earth, about 356,000 kilometers away. At such times, its presence feels a little stronger in the sky, a little larger, its light more insistent. Later in the month, during the next new moon, it would drift much farther out, nearing 420,000 kilometers, stretching the invisible bonds between Earth and Moon to their longer limit. Between these 2 points, the geometry of the inner solar system formed a delicate pattern, with Mercury passing between Earth and the Sun in what astronomers call an inferior conjunction, joined closely in line with Uranus. These arrangements are quiet and precise, like the alignment of gears turning without sound. At the same time, Earth moved through a stream of ancient debris left behind by a long disintegrated comet, known as the Taurid meteor stream. Each year, in June and again in November, this river of particles intersects Earth's orbit. Most of the pieces are tiny, no larger than grains of sand, burning up harmlessly as brief streaks of light. Some, however, are larger, pebble-sized or more, creating slower, brighter fireballs that linger for a moment longer in the sky. In certain years, based on the rhythm of Earth's orbit and the structure of the stream itself, these encounters grow more frequent. The years 2025 and 2026 are among those expected to bring such clusters. Already, more of these bright visitors have been appearing, quiet flashes reminding us that space is not empty, only thinly populated. Far below, Earth's surface showed signs of its own internal motion. Along the coast, near Kamchatka, Russia, a magnitude 6.1 earthquake occurred, followed by a swarm of smaller tremors. The crust adjusting along deep fractures. In Afghanistan, a magnitude 6.3 earthquake struck within the same day. These movements arise from forces locked inside the planet itself, driven by slow heat and pressure, releasing suddenly after long restraint. Their timing alongside solar and lunar events does not assign cause, but it does remind us that Earth is never truly still. In the atmosphere, powerful storms gathered energy over warm oceans. A strong typhoon, named Kalmayegi, approached the Philippines, its vast spiral drawing strength from heat and moisture below. Such storms are born from Earth's own systems, shaped by temperature differences and rotation. Vast, yet familiar in their patterns. Back at the Sun, another feature rotated slowly into view, a large coronal hole, an area where magnetic field lines open outward instead of looping back to the surface. From these regions, streams of faster solar wind flow more freely into space. As this coronal hole turned toward Earth, its outflow lined up with our planet's path, increasing the chance that the magnetic environment around Earth would feel a stronger push in the days ahead. None of these movements stand alone. They overlap in time, not by design, but by the simple fact that everything in the solar system is always in motion. The Sun turns, Earth orbits, the Moon circles, debris drifts, fields shift, plates move, storms form and fade. Sometimes these rhythms coincide closely enough to feel like a wave building, a period where many systems seem active at once. Right now, the measurements show the Sun holding at an elevated level of activity compared to recent days, shaped by returning sunspots and recent flares, with the after effects still traveling outward through space. This is where we are right now. When scientists step back and look at the Sun over long stretches of time, something gentle but persistent begins to emerge. The Sun is not constant. It breathes. Its activity rises and falls in slow rhythms that take years to unfold, too gradual to notice day by day, yet unmistakable when viewed across decades. One of these rhythms spans about 11 years, a cycle marked by the waxing and waning of sunspots, flares, and magnetic complexity. Right now, the Sun is moving through what is known as Solar Cycle 25, a chapter in that long story where activity has climbed toward a maximum and has begun its gradual descent. This descent does not mean quiet. In fact, some of the most striking events often occur near these turning points, when the Sun's magnetic fields are still tightly wound, adjusting themselves into simpler shapes. Looking back, there is a familiar echo here. In late October and early November of the year 2023, the Sun released a series of unusually strong storms, moments when its surface cracked open with energy that traveled far into space. Those events occurred almost exactly 1/2 of a deeper rhythm ago, a modulation that spans about 22 years, sometimes called the Hale cycle. In this longer rhythm, the Sun's magnetic polarity completes a full reversal and return, like a slow turning of a compass needle through a full circle, seeing large, active sunspot groups now, alive with motion and flare-producing energy. at nearly the same point in that deeper cycle, does not feel accidental. It feels like a familiar verse, returning in a song that has been playing far longer than human memory. Scientists notice these repetitions, not because they promise drama, but because they suggest structure. The sun follows rules written in magnetism and plasma, rules that allow patterns to reappear even as individual events remain unpredictable. Against this broader background, the recent flare stands out quietly but clearly. It was the strongest solar flare observed since June of this year, reaching a level measured as 5.0 on the M-class scale. There have been other strong releases in recent months, flares that reached 4.8, 4.6, brushing close to this level, but none quite crossing the same threshold to find a truly stronger event. One must look back to June 19th, when the sun produced an X-class flare measured at 1.91, a rare and intense release that briefly pushed the sun into its highest category of flare strength. These classifications are not judgments of danger, only markers on a ladder of energy output. They help scientists understand how much radiation was released and how likely it is that material was launched outward along with the light. A flare near the top of the M-class range sits close to that boundary, a place where eruptions become more capable of stirring the space between the sun and Earth. That this event arrived after months of slightly lower activity makes it notable, not because it is unprecedented, but because it signals that the sun is still capable of strong expression as this cycle unfolds. When such activity increases, its effects do not remain confined to the sun. Streams of charged particles can travel outward, carried by the solar wind, interacting with Earth's magnetic field when they arrive. During periods like this, Earth's magnetic environment can experience larger swings, gentle on human senses, but measurable by instruments. The magnetic field stretches and compresses, adjusting to the changing pressure from space. In response, curtains of light appear near the polar regions, auroras shimmering softly over the Arctic and Antarctic circles. At times of stronger geomagnetic storms, these lights wander farther from their usual homes. They slip into higher mid-latitudes, sometimes even lower, surprising those who rarely see them. The exact reach depends on the strength and orientation of the incoming solar material. An extreme storm can push these luminous patterns far toward the equator, while milder ones keep them closer to the poles. With the sun entering a more active phase, the probability of such displays increases over the coming couple of weeks. Not as a certainty, but as a quiet statistical tilt. All of this unfolds within a broader setting already filled with motion. The moon is approaching a full supermoon, a time when it appears brighter and larger because it is closer to Earth than usual. At this distance, its gravitational pull is slightly stronger, subtly amplifying tides in oceans and even in the solid Earth. These effects are small but real. Measured carefully over long periods, they do not command events, but they add a gentle emphasis, like a hand resting a little more firmly on a scale. Earth is also passing through the torrid meteor stream, a wide and diffuse ribbon of debris left behind by an ancient comet. Most of these particles are tiny, but some are larger, entering the atmosphere as slow, bright fireballs that linger in the sky. In certain years, based on orbital resonance between Earth and this stream, these encounters become more frequent. The years ahead, including 2025 and 2026, are among those when this resonance is expected to be more pronounced. Even now, the stream contributes a steady presence, a reminder that Earth's orbit intersects with the remnants of older solar system stories. Another presence adds to this layered moment. Comet A6 Lemon is approaching perihelion, its closest point to the Sun. Scheduled for early November, unlike planets, which remain close to the flat plane of the solar system, this comet travels on a steep path, rising above and then dropping below the ecliptic plane as it sweeps inward. From afar, it has journeyed from well beyond the familiar bounds of planetary orbits, carrying ice and dust preserved from the solar system's earliest days. As it nears the Sun, warmth awakens it. Ice begins to sublimate, releasing gas and dust that are immediately shaped by sunlight and solar wind into a long, luminous tail. This tail is not merely decorative, it is a visible sign of intense interaction with the Sun's electromagnetic environment. Around the comet forms a complex structure, a cometopause where solar wind pressure balances the comet's outflow, an ionopause where charged particles gather, and a bow shock that forms as the comet plows through the streaming plasma. Much like a boat pushing through water, the geometry of this moment is quietly striking. From Earth, observations of the Sun are always made looking straight on. Earth, Sun, and instruments aligned along a single line of sight. During this period, Comet A6 Lemon appears offset to the side, not in a perfect right angle, but close enough to share the same broad region of space as the active sunspot groups rotating into view. As the days pass from the 3rd toward the 8th of November, the comet remains near its closest approach, lingering in a zone where solar energy is strongest. Its tail stretches long and bright, evidence of volatiles, dust, and plasma being released continuously. This activity tells scientists that the comet is highly energized, responding dynamically to the Sun's radiation and magnetic fields. It is not influencing events on Earth directly, nor steering solar behavior, but it is participating fully in the same energetic environment. Another ancient traveler, illuminated and shaped by the same forces now stirring the Sun. All of these motions are unfolding within the same stretch of time. Overlapping without announcing themselves, the Sun continues to turn, its active regions slowly shifting across the face we observe. Earth moves steadily along its path, its magnetic field adjusting in small, measurable ways. The moon draws nearer, brightening the night a little more than usual. Fine remnants of ancient debris slip quietly into the atmosphere. While far from Earth, a comet moves through intense sunlight, shedding gas and dust into a long, luminous trail shaped by invisible currents. Nothing here stands apart. Each part simply occupies its place, responding to the same forces, moving through the same space. As the flow of energy through the solar system continues without pause, the alignment unfolding during this stretch of time is not dramatic in appearance. Yet it carries a quiet weight for those who spend years watching how space arranges itself on the visible face of the Sun. Several active regions are rotating steadily into view, carried along by the Sun's slow, patient spin. Among them, one large sunspot group in the northern hemisphere draws particular attention, not because it is new, but because it is complex. Its structure is dense, its magnetic fields tightly wound, layered over one another like threads pulled too close together. Regions like this tend to announce themselves gradually before the largest releases occur. There are often smaller signals, modest flares that suggest stored energy is beginning to find pathways outward. That is already happening here. Activity has been observed from this region, and experience suggests it rarely stops at just one expression. When magnetic tension on the sun begins to unwind, it often does so in a sequence, each release slightly reshaping the field, sometimes making the next release easier. Trailing behind this dominant group are others, still partially hidden near the sun's eastern edge. They have not yet fully faced Earth, but their presence is known, their magnetic complexity already measured. As the sun continues to rotate, these regions will move into clearer view. This slow procession gives the moment a sense of continuity rather than surprise, a reminder that solar activity unfolds over days and weeks, not seconds. Within the past 24 hours, the sun has offered a clear example of this unfolding. A large coronal mass ejection lifted away from the solar surface, a vast cloud of charged particles expanding outward into space. Not long after, a second ejection followed, close enough in time that the two appear almost connected. The first was associated with a flare measured at 5.0 on the M-class scale. The second with a 3.3 M-class flare. Together, they form a paired release, like two waves generated by the same disturbance. When scientists observe these ejections, they pay close attention not only to their brightness, but to their shape. In this case, the expanding material does not form a perfect ring around the sun. Instead, it spreads unevenly, stronger in one direction, creating what is known as a partial halo. Most of the material travels away from Earth's direct line, but the outer edge extends wide enough that part of it is likely to pass near our planet. This kind of encounter is not expected to be intense. It is more like a brush along the edge of a current. Noticeable, but not overwhelming. Even a glancing encounter, however, carries information. It reveals the orientation of the sun's magnetic fields, the speed of the solar wind, and the responsiveness of Earth's own magnetic shield. If the trajectory holds, this outer edge may arrive in roughly 3 to 4 days. When it does, it will merge seamlessly with the background flow of particles that already fills the space between Sun and Earth. The arrival will be quiet, marked not by spectacle, but by small adjustments in magnetic readings and subtle shifts in the near-Earth environment. While solar material makes its slow journey outward, Earth continues to move through regions shaped by much older processes. One of these is the Taurid meteor stream, a broad and uneven trail of debris that intersects Earth's orbit twice each year. This stream is the remnant of a body that broke apart long ago, shedding dust, the stones, and larger fragments along its path. Over time, gravity has stretched this material into a wide river of particles circling the sun. Within this river lies a denser region, sometimes called a resonant swarm. The particles there follow orbits that resonate with those of larger planets, keeping them clustered rather than evenly dispersed. As Earth approaches this region, the likelihood of encounters increases. Most of these encounters are inconsequential, tiny grains vaporizing high above the surface. Some, however, are larger, producing slow-moving fireballs that glow intensely as they pass through the atmosphere. From the ground, these meteors appear to emerge from the same part of the sky within the constellation Taurus. Taurus is an ancient figure, easy to recognize once known. Aldebaran shines steadily, a warm point of light marking the bullseye. Nearby, the Pleiades cluster gathers a handful of faint stars into a tight group, often described as a small cloud or a sprinkling of frost against the dark. These landmarks anchor the region from which the Taurids appear to flow. The stream itself has two branches, northern and southern, each peaking at slightly different times. The southern branch typically reaches its height around the 5th of November, while the northern branch follows a few days later, near the 9th. These peaks are gentle, not sudden, building and fading over several nights. The fireballs associated with this stream are distinctive, not because of their speed, but because of their slowness. They move deliberately, giving the impression of something heavy and ancient, passing briefly through the modern sky. Sharing this region of space during the same window is the planet Uranus. From Earth's perspective, Uranus appears near the Pleiades during this period. This alignment is uncommon simply because Uranus moves so slowly, completing a single orbit around the Sun in about 84 years. Such proximity does not imply interaction or influence. It reflects geometry, the coincidence of paths crossing in our line of sight. Still, for observers, it adds another layer to the scene, another reminder of how many independent motions can overlap without touching. Viewing these skies is shaped by light from closer companions. The full supermoon brightens the night, lifting shadows and softening contrast. Under such conditions, faint meteors are harder to see, their brief flashes swallowed by moonlight. Yet Taurid fireballs often remain visible even then, their brightness and length allowing them to stand out. If geomagnetic activity increases, auroras may add their own glow to northern or southern horizons, coloring the darkness with slow-moving curtains of light above Earth. These changes extend into the realm of technology. The upper atmosphere responds to solar energy by warming and expanding. When this happens, satellites in low Earth orbit encounter slightly thicker air, increasing drag. Over time, this can alter orbits, requiring adjustments to keep satellites on track. Individually, these effects are small. Collectively, as the number of satellites grows, they become more noticeable, more frequently measured. Solar activity can also influence satellites through electrical charging. Energetic particles accumulate on surfaces and within insulating materials, sometimes leading to brief disruptions. These effects are studied carefully, not as signs of failure, but as part of understanding how human-made systems coexist with the dynamic space environment. The space around Earth is no longer empty, and so its subtle changes leave clearer fingerprints. Returning again to the Sun, another feature quietly shapes the flow of energy outward in images that isolate specific wavelengths of light. The Sun's corona reveals regions that appear darker than their surroundings. These darker areas are coronal holes, places where the magnetic field opens outward instead of looping back to the surface. Plasma density there is lower, allowing solar wind to escape more freely and at higher speeds. From these regions, fast streams of solar wind emerge, often reaching speeds of 600 700 or even 800 kilometers per second, compared to slower background wind. These streams carry fewer particles per unit volume. Their density drops even as their velocity increases. Recently, Earth encountered such a stream. Instruments recorded elevated speeds while particle density hovered around 1 particle per cubic centimeter. Later, rising toward 2, these values are not fixed. They drift and fluctuate, tracing the invisible currents flowing past our planet. Some researchers track these measurements alongside seismic records, exploring whether extended periods of very low particle density coincide with increased earthquake activity. This remains an area of investigation rather than conclusion. What is firmly observed is the timing. The coronal hole responsible for this stream spans both northern and southern regions of the Sun, allowing its influence to persist as the Sun rotates. As this coronal hole turns further into an Earth-facing position, its high-speed wind continues to blend with the surrounding solar flow. Nearby, sunspot groups progress steadily across the Sun's disk, releasing energy in bursts large and small around Earth. Particles, magnetic fields, moonlight, and meteors all share the same interval of time, each responding according to its own nature. Nothing here arrives in isolation, and nothing resolves all at once. The system remains layered and active, its motions continuing quietly, moment by moment. When the focus shifts from the Sun and the space around Earth down to the planet itself, the story does not become louder. It becomes heavier, slower, carried by processes that unfold beneath continents and oceans. Mostly unseen, looking across the seismic record of the year 2025, beginning in the middle of summer and extending forward month by month. The activity does not scatter randomly across the globe. Instead, it arranges itself into sequences, clusters of movement separated by intervals of relative calm, like long pauses between deep exhalations. The record begins to stand out clearly in July. During that period, Earth released an extraordinary amount of stored energy in a short span of time. The most powerful event in that cluster reached a magnitude 8.8, a level of motion that reshapes entire regions of the planet. Earthquakes of that size do not simply shake the ground locally. They alter stress patterns across vast distances, sending waves through the crust and mantle that continue traveling long after the surface has settled. Around this largest release appeared other powerful events. Earthquakes in the high 7 range followed a magnitude 7.5. Then a pair close together at 7.4 and 7.8, followed by another at 7.7. Each of these numbers represents a tremendous release of energy, far beyond what everyday experience can easily grasp. A magnitude 5 can wake people from sleep. A magnitude 6 can damage buildings and change landscapes. Magnitudes above 7 move entire sections of the planet at once. What draws attention in this sequence is not only the size of the events, but their spacing. When the dates are placed side by side, a rough rhythm emerges from one major cluster to the next. The interval measures close to 28 days, not exact, not rigid, but close enough to suggest that the system is cycling through a familiar state, releasing energy, settling briefly, then releasing again. This near-monthly spacing becomes more compelling when viewed alongside conditions in near-Earth space during the same periods. Each time one of these high-magnitude earthquakes occurred, a similar solar configuration was present. A coronal hole, positioned near the western limb of the Sun, had recently rotated through an Earth-facing alignment. At the same time, measurements showed Earth immersed in a low-density solar wind regime, where particle counts dropped even as wind speeds remained elevated. These conditions did not create earthquakes. The forces that drive seismic activity arise from heat, pressure, and motion deep within Earth itself. But the repetition of these space weather conditions alongside major seismic releases is difficult to ignore. It suggests that Earth's systems do not operate in isolation. They exist within a broader environment, responding subtly to changes above as well as below. Now, those same conditions are returning. The coronal hole that played a role in earlier periods of activity has not vanished. It has persisted, rotating with the sun, maintaining its structure. As the sun turns, this region once again approaches an alignment where its influence becomes geo-effective, meaning its outflow connects efficiently with Earth's magnetic environment. The timing aligns closely with the same near-monthly interval observed earlier in the year. One detail of this coronal hole matters especially. It spans across the solar equator, extending from the northern hemisphere into the southern. Because of this transequatorial structure, the high-speed solar wind it releases does not pass cleanly above or below Earth's magnetic field. Instead, Earth lies directly in its path. When coronal holes are confined clearly to one hemisphere, their streams can sometimes miss the planet. This one does not. In addition, the magnetic polarity of this region appears oriented in a way that allows for strong coupling with Earth's magnetic field. This does not force energy into the planet, but it does allow interactions to occur more efficiently. These interactions are measured carefully, tracked over time, and compared with other geophysical data. They form part of an ongoing effort to understand how different layers of Earth's environment respond together. As this solar configuration begins to re-establish itself, Earth has already shown signs of renewed motion. Within the most recent 24 hours, a magnitude 6.3 earthquake struck Afghanistan. For those nearby, such an event is unmistakable. The ground moves sharply, structures strain, and the sense of stability is briefly lost. Anyone who has experienced an earthquake above magnitude 6 understands how deeply physical the experience is. Even a magnitude 5 can feel violent. A 6 reshapes perception. Soon after, a magnitude 6.1 earthquake occurred near Kamchatka, part of a region that has been particularly active throughout the year. These events did not occur in isolation. They join a broader pattern that includes numerous earthquakes in the 5 range and many smaller tremors. Together, they indicate that a large amount of seismic energy is being released across this zone. Another notable event during this period was a magnitude 5.5 earthquake in Chile. While not the largest of the day, it was still strong enough to be widely felt. Around it, other earthquakes filled the record magnitudes: 5.8, 5.1, 5.0, and a series of 4s. Each release adds to the overall picture of a planet actively adjusting its internal stresses. This region of heightened activity has been one of the primary sources of seismic energy release for the year. The energy does not remain confined to the point where the ground breaks. It propagates outward through Earth's interior, traveling as seismic waves that spread across continents and oceans alike. Near the epicenters of the largest earthquakes, the ground enters what is known as an earthquake shadow. In these zones, stress has already been released. Faults that slipped recently are less likely to rupture again in the immediate future. the Earth there has, for the moment, relieved its tension. But this relief comes at a cost elsewhere, beyond the shadow zones. Stress is redistributed. Energy that once pressed evenly across a broad area is redirected outward, loading neighboring regions with additional strain. These areas may not move immediately. They may hold the added stress quietly, accumulating it over time. This process does not follow human boundaries or simple distances. It travels through rock, guided by the structure of the planet itself. Regions such as Japan, the Aleutian Island chain, and Alaska sit within reach of these redistributed stresses. Even farther away, the western edge of North America lies along pathways where seismic energy can eventually influence fault systems. The distances involved are vast, yet the planet remains continuous. What moves in one place subtly alters conditions elsewhere. Wave visualizations help make this process visible. From the moment a large earthquake occurs, seismic waves radiate outward in all directions. They travel first through nearby land, then beneath oceans, passing through layers of crust and mantle. On maps, these waves appear as expanding rings, often colored to show upward and downward motion. Red indicates ground rising, blue indicates ground falling. In reality, this motion is not abstract. During strong earthquakes, the ground behaves differently than we expect. For brief moments, it loses its familiar rigidity. It flexes. It ripples. People who have been outdoors during major earthquakes often describe seeing the ground move like waves on water, slow and rolling, as though the solid earth had become temporarily fluid. The recent magnitude 6.1 earthquake did not produce visible waves across continents, but it contributed to the broader pattern of motion. Its energy still traveled outward, joining the background vibration passing through North America and Eurasia. These waves do not create new earthquakes by themselves, but they modify stress conditions, sometimes enough to matter. All of this unfolds while another influence quietly approaches: the full supermoon. Arriving on the 5th of November brings the moon closer to Earth than usual. At this distance, its gravitational pull strengthens slightly. Ocean tides rise a bit higher. The solid Earth experiences small but measurable tidal stresses. These forces are gentle compared to tectonic forces, but they are constant, repeating, and precise. The moon does not command earthquakes to occur. Its role is subtler. It modulates stress, adding a small, rhythmic influence to a system that is already under pressure. In regions near a breaking point, even small changes in stress can matter. They do not determine outcomes, but they become part of the overall condition. As seismic waves continue to travel through continents, as stress redistributes from one region to another, and as lunar gravity slowly intensifies toward the full supermoon, the planet remains in a state of adjustment. Energy released days or weeks earlier continues to ripple outward. Faults respond not all at once, but according to their own thresholds and histories. Nothing here resolves immediately. The Earth holds the memory of recent motion within its rocks. Waves pass, fade, and leave behind altered conditions. Above it all, the moon draws nearer, brightening the night sky, while the ground beneath remains quietly engaged in its long, patient work. Ocean tides are only the most familiar expression of the moon's pull. there is another tide as well, quieter and easier to forget, because it happens beneath our feet. The solid earth flexes, too, not like a wave on water, but like a slow bend in a vast, resilient body. When the moon comes unusually close, that gentle flex can reach one of its stronger points for the cycle. A subtle vertical rise and fall measured in careful instruments and patient graphs. It is not something most people feel directly, yet it is always there in the background. A steady reminder that ground is not the same as still. To picture how many motions overlap at once, it helps to step into a sky map that shows where the bodies of the solar system really are, against constellations drawn at their true sizes rather than tidy textbook shapes. In that view, the sun sits near the edge of Virgo, preparing to slip onward, while Venus remains in that same region, bright and close to the sun's line from our perspective. And moving through the sky near Venus is the interstellar visitor known as 3I/Atlas, around today and into tomorrow, the 5th of November. As seen from Earth, its position draws close to Venus in the sky, a conjunction in the simple, visual sense, two objects sharing nearly the same line of sight from our vantage point. It is important to hold that gently. Without adding weight, it does not carry. A conjunction is geometry, not a handshake. The two bodies are not meeting in space. They are simply aligned for us, like two distant lanterns appearing to overlap when you look down a long road. Still, that alignment has a particular kind of quiet poetry to it. Venus, wrapped in thick cloud and bathed in solar light, has recently been on the receiving end of repeated bursts from the sun streams of charged particles and radiation that sweep past her orbit as easily as they sweep past ours. In the language of measurements rather than metaphor, Venus is embedded in the same changing solar wind environment. And in the language of a bedtime sky story, she has been standing in bright weather for days. Nearby on the chart, Mars and Mercury appear close together as well. Another conjunction again. Not a collision, but a shared direction. Mercury stays near the sun, never straying far in our sky, while Mars moves with a slower dignity, farther out, rather quieter. Their closeness is a momentary overlap from our line of sight, a reminder that the sky is not a flat dome, but a layered depth of paths crossing at different speeds. And then there is the moon, moving the way it always does, sweeping across the map in a steady arc. Night by night, it changes its position, passing by the bright anchors of the sky and gliding near planets that seem, from Earth, like colored points. On this path, it approaches the region where Saturn and Neptune sit, distant worlds that rarely draw attention in casual stargazing, yet always present in the chart. Along the same broad band of the ecliptic are smaller members of the solar system as well, dwarf planets, and objects with more complex classifications, such as Chiron, which travels between the outer planets on an orbit that doesn't fit neatly into the old categories. These names can feel like labels pinned to darkness, but the reality behind them is simple and calming. Many bodies share the same gravitational architecture, and the moon, from our viewpoint, passes their neighborhood in the sky as it continues its cycle. Farther along that same band sits Uranus, faint to the eye without optical help, but well placed on the map. A marker of how wide the solar system truly is. The moon's motion brings it toward a familiar geometry, first opposition with the sun. Around the 5th and 6th of November, the moon reaches the configuration we call a full moon when it stands opposite the sun in the sky. Earth in between. Sunlight falling fully on the moon's visible face. This is the full supermoon in the story you have been following. Made super, not by any change in what the moon is, but by where it is along its elliptical path closer to Earth than average. Brighter in our sky. A little larger to the eye. As the days slide forward, the moon keeps traveling. It does not remain at opposition for long. It shifts, night by night. And in that shifting, it passes close to Uranus from our perspective. A conjunction again, Moon and Uranus, sharing nearly the same direction in the sky for a brief time. An alignment that is visually interesting. Even if it is physically distant, the moon is close in cosmic terms. Just a few light seconds away, Uranus is vastly farther. Many billions of kilometers from us. Yet for a night or two, their positions can seem to meet in the same small patch of darkness. If the chart is carried forward farther still, toward the 20th of November, the geometry becomes more intricate. The moon approaches its new phase then. The point in the cycle when it lies near the sun's direction in the sky. Its lit side turned away from us. The night becoming darker again. At the same time, Mercury moves through its own turning point. Mercury's motion can appear to slow against the background stars. A stationing that precedes a period when it seems to move backward in our sky. A retrograde motion that is only apparent an effect of our changing viewpoint as both planets orbit the sun. During this window, Mercury also reaches an inferior conjunction, passing between Earth and the sun. When that inferior conjunction happens very close to the sun's disk in the sky, it is sometimes called a Cassini configuration, an alignment so tight it feels, on the chart, like a precise needle threading through the center. On the 20th of November, the map shows an alignment that is striking in its symmetry. The moon near the sun's direction in the new phase, Earth on its path, Mercury close to the sun from our viewpoint at inferior conjunction, and Uranus positioned roughly opposite on the far side of the sky. The angles on such charts can be measured with great precision, down to degrees and arc minutes. In this case, the separation is on the order of 15 degrees and 18 arc minutes in one of the key relationships being highlighted, with Mercury also placed near 15 degrees in that same framework. These are the kinds of details that charts love to display, numbers that make the geometry feel crisp, like lines drawn with a careful hand. It is worth keeping the tone gentle here. Such precision is real in the sense that positions can be computed and plotted accurately. The sky truly does arrange itself this way at that time. What we do not do, if we want to stay anchored to science, is treat geometry as destiny. Alignments do not command events. They do not push buttons on Earth. They are simply the arrangement of bodies moving according to gravity. Viewed from a particular place at a particular time, their value is clarity. They show us where we are, how the system is oriented, how many motions can overlap without touching, even without mystical weight. There is something quietly affecting about this particular lunar cycle. It layers together a close full moon, a new moon later in the month, and the quick, subtle turning of Mercury's apparent motion, all while the sun itself is active, releasing energy in bursts that we have already watched unfold. It can feel, from inside human life, as though many dials are being adjusted at once. From the standpoint of physics, what we are witnessing is a set of independent cycles coinciding the Moon's monthly rhythm, Mercury's inner orbit geometry, Uranus's long, slow placement on the far side of the chart, and the Sun's magnetic restlessness expressed through increased radiation and solar wind structures. The Moon's role in Earth's space environment is not only gravitational. During a full moon, the Moon's position carries it through regions shaped by Earth's magnetic field. Earth's magnetosphere stretches away from the Sun like a long, invisible windsock, compressed on the day side and drawn out into a magnetotail on the night side. The Moon can pass through parts of that extended tail, moving through a realm where charged particles and magnetic fields form a complex, shifting landscape. Nearby is the plasmasphere, a torus of relatively cold, dense plasma that co-rotates with Earth, swelling and shrinking with geomagnetic conditions. None of this is easily seen with the eye, but it is continuously measured and modeled. A kind of weather system made of particles and fields rather than clouds and rain. When the Sun is more active, this invisible weather becomes more variable. Solar flares increase the output of high-energy radiation radio frequency emissions that can change the ionosphere's behavior. Extreme ultraviolet light that heats and alters the upper atmosphere, and X-ray light that can intensify short-lived absorption in the layers where radio waves travel. Coronal mass ejections and high-speed solar wind streams add slower, heavier changes, shifting magnetic pressure, altering currents, raising the odds of geomagnetic storms that ripple through Earth's field. In a purely physical sense, this means the environment around Earth becomes more energized, more dynamic, more responsive. It is tempting, in moments like this, to treat the whole thing as a single wave marching toward a dramatic crest. A more careful way to hold it is softer, many small contributions adding together, sometimes reinforcing, sometimes passing without much interaction. The Sun brightens in energetic wavelengths for minutes or hours at a time. The solar wind changes over days. The Moon's gravitational pull rises toward its closest point and then eases away. Mercury's geometry tightens and then loosens. The Earth's crust continues its slow adjustment beneath all of it. These cycles overlap the way ocean swells overlap, not one commanding the others, but each adding texture to the surface of the same wide sea, because the source material you brought includes personal recommendations, earthing, breathwork, dietary advice, and similar guidance. This is the point where the tone needs to stay honest and safe. There are gentle things a person can do that are universally reasonable: resting when tired, keeping stress low when possible, stepping outside for a moment of fresh air and perspective, and taking care with routines that support steady sleep. But it would not be responsible to claim that specific practices can protect someone from solar activity, prevent earthquakes, or control the body's response to space weather. The science does not support that kind of certainty. What the science does support is simpler and perhaps more comforting. These forces are large, ancient, and mostly outside our control, and yet our lives continue within them, one ordinary night at a time. So the practical posture here is not fear and not bravado. It is attention without strain, knowing that the Sun has become more active, It makes sense to expect that geomagnetic conditions may vary more than usual, knowing that the moon is close. It makes sense to remember that tides, both ocean tides and earth tides, are slightly emphasized, knowing that our technological systems in orbit are sensitive. It makes sense that occasional anomalies can occur during stronger space weather periods. None of this asks you to brace for catastrophe. It asks you only to recognize that we are living inside a system that is moving. The language of preparation can be held gently. 2. Preparation does not have to mean stocking supplies or anticipating worst-case scenarios. It can mean something as quiet as not overloading your mind with anxious interpretation. It can mean leaving room for the possibility that the next few days include brighter auroras at higher latitudes, or a few more radio disruptions on the daylight side, or a night when the sky feels unusually bright because the moon is near, washing the stars with pale light. It can mean respecting that the Earth is active in its own slow way, releasing energy where it must, without implying that any one person can predict where or when the next large rupture will happen. And still, the chart keeps moving forward with calm inevitability. The sun's position edges away from Virgo. Venus remains nearby in the sky, luminous and close to the sun's line. 3I/Atlas passes through that same region from our viewpoint. A visitor with a long memory, traveling on a trajectory that does not belong to the planets. Mars and Mercury share a brief closeness. The moon sweeps on, passing Saturn, passing Neptune, passing the quieter names that occupy the edges of the map, then sliding into opposition with the sun around the 5th and 6th of November. Brightening into a full supermoon, it continues onward, drawing near Uranus in the sky for a short time. Then, by the 20th of November, arriving at the new phase while Mercury folds into its inferior conjunction near the Sun, and Uranus holds its opposite position across the chart, above Earth. The magnetotail stretches and flexes under the Sun's changing pressure. The plasmasphere swells and thins. The ionosphere brightens and absorbs differently depending on solar radiation. Radio frequency emissions rise and fall. Extreme ultraviolet output warms the upper atmosphere. X-ray light spikes and fades. These are not poetic exaggerations. They are measurable realities, traced in instruments that turn invisible processes into quiet lines and numbers down on Earth. The tides respond. Not only the visible tides of water, but the subtler tides of rock. The planet lifts and settles by small amounts as the moon draws nearer. The vertical displacement reaching one of its stronger moments in this cycle because the moon is close. On top of that slow flex, seismic energy continues to move through the crust and mantle. Waves from recent earthquakes traveling outward long after the moment of rupture, redistributing stress, altering conditions in ways that only become clear over time. The night sky, brightened by the approaching full moon, may hide some of the faintest details, yet the system itself is still there, turning quietly, layer upon layer. The sun's activity has increased, sending more high-energy light outward. The moon's closeness strengthens the background rhythms of tides. Mercury's geometry tightens toward a rare-looking alignment on the 20th of November, and through it all, Earth continues to adjust in its own slow language of pressure and release. With no need for dramatic narration, only the steady fact of motion. Still unfolding, still gathering its patterns, and ending as the voice in the original source does. with a sentence that trails off into what comes after. I'll see you all in the next